Hello everybody, so today I will talk about double integrals. So I will show you the technique how to answer this one. So we need to put about s to the power of 2 in here. So that means we need to minus s to the power of 2. This one divide this one, so you got about 1 minus over s square over s square plus y square. And now we can get the final answer of this one. The integral of number 1 of dy, so you got about y. The integral of this one, you got about s multiplied with r times of y over s, and we have the powers in here. And now we put the number in here. So I will calculate first integral in here. Later that we will go to the second one. So we need to use about integration by trigonometric substitution. So we put about s equal to 5 sin t, ds equal to 5 cosine t dt. Later that we need to change the negative number 1 and negative number 5 and number 5 in here. So we got about s equal to negative number 5. So we put negative number 5 in here, and we can find the value of t equals to negative p over 2. Similar for s equals to number 5. So you got about t equals to p over 2. So we put b over 2 in here and here. This one we change about 25 sin t square. The s we change for 5 cosine t dt. The square root of 25, you got about number 5. One minus sin t square, you got about cosine t square, and you got about cosine t, and we have 25 cosine t square, and we know that cosine t square we can change about cosine 2t plus 1 over 2, and we can get the final answer. The integral of cosine 2t, you got about 1 over 2 sine 2t, and we have t, and we put the powers in here. So this one you got about 25b over 2. Now let's go to the second one. In this situation, we can use about integration by parts. So we have u and dv. U equal to s, so you got about du equals to ds. Dv, we got about this one. Oh, sorry, we need to put this one in here. So du equals to negative 1 over the square root of 25 minus s squared. Dv, that's about s. ds equal to v s squared over 2. So this one, we got about u multiplied with v. And we have the negative in here, so you got about the positive. We put the number 5 and negative number 5 in here. You got about 0. So this one go to 0. So we don't need to calculate this one. So we just concentrate about this one. So in this situation, we can use about integration by trigonometric substitution. So we work about s equal to 5 sine t, ds equal to 5 cosine t dt. So this is similar for this one. So we put this one in here. This one you got about 25 sine t squared. This one we change to 25 sine t squared. ds we change for this one. The square root of 25, you got about number 5. One minus sine t squared, you got about cosine t squared. And this one you got about cosine t. And this one they will cancel. And then you got about 25 over 2, and we have sine t squared dt. This one we can change about 1 minus cosine 2t over 2. So you got about the final answer. The integral of number 1, you got about t. The integral of negative cosine 2t, you got about negative 1 over 2 sine 2t. And we put the bounds in here. So you got about 25b over 4. And now we need to combine the answer. So we have this one minus this one, and you got about 25p over 4, and that's it, the final answer. This is the end. Thank you for watching.